In this video, I will be going over your Exam 5 review. Alright, first question. So we have a figure B is a scale image of figure A as shown. What is the scale factor applied to figure A to produce figure B? Alright, so for scale factor, remember all we need to do is put our new image over our old image. Okay, so figure B is our scale factor, which makes, or scaled image, which makes figure B our new image. So new is going to be 9, and old is going to be A, and that's 2.5. So my scale factor here will be 9 over 2.5, and that is it. We don't need to simplify or reduce, just leave the fraction there. We would just type in 9 over 25. Our next question says that a scale drawing of a rectangle bedroom is shown below. Using the scale of 1 centimeter equals 4 feet, enter the actual area of the bedroom in square feet. Okay, so I know that my bedroom here is 3 by 5 by 2.8, and I have this scale factor of 1 centimeter is equal to 4 feet. So what I need to do is take both of these sides and multiply it by 4. And when I'm multiplying this by 4, that is going to give me the actual side lengths of this bedroom. Okay, so again, you can use a calculator. I'm going to pull mine over really quick. I'm going to do 3.5 times 4, and I'm going to do 2.8 times 4. So I get 14 and 11.2. So what I'm going to do is draw a new rectangle, like this, and I'm going to have my 14 feet on top and my 11.2 feet on the side. To find the area of a rectangle, all I do is take length times width, so I would do 14 times 11.2. Bring back my calculator, 14 times 11.2. This is going to give me 156.8 feet squared. So my answer here would be 156.8 feet squared. And again, I used my scale factor of this and multiplied my length and width by 4, because 1 centimeter is equal to 4 feet. Then I take those two numbers, multiply them together to get the area of my bedroom. And our next question says, which of the following figures maps a scale factor from figure A to figure B of 1 to 1.5? Select two that apply. So on this one, we want to do something similar to what we did before. Notice here we have this scale factor of 1 to 1.5. On this last problem, we had a scale factor of 1 to 4. So I took all of my sides and multiplied it by this 4 here. We're going to do the same exact thing, and we're going to take all the sides on figure A, and we're going to multiply it by 1.5. And what we're looking for is to see if we get these dimensions on figure B when we multiply it. Okay, so for figure A, I'm going to take 1.9 and multiply it by 1.5, and then I'm going to take 3.3 and multiply it by 1.5, and I'm looking to see if I get these two side lengths here. If I do, perfect, that one counts. If I don't, then that one does not count. So I'm going to bring my calculator back. I'm going to do 1.9 times 1.5. And see here, I get 2.85. That's good. And then let's check that last one, 3.3 times 1.5. And I get 4.95, which is this side here. Perfect. So this one is a correct answer. This figure would count. Let's check our next one. So on the next one for figure A, I have this 1.6 and 4.5. So 1.6 times 1.5, 4.5 times 1.5. And bring back our calculator. So I have 1.6 times 1.5, 4.5 times 1.6. Whoops, nope, 1.5. There we go. So here I can see I get a 2.4 and 6.75. And when I look at this figure here on B, these side lengths here are not the same, right? That's not the same numbers I'm getting, which means that this image is not correct because those side lengths are not the same. Now let's check the third one. So again, I'm going to take both of these side lengths and multiply it by 1.5 like I did in the first two. So I'm going to do 2.8 times 1.5, and I'm going to do 0.4 times 1.5. And here, see how I get 4.2 and 0.6? And if I look at the image, I get 4.2 and 0.6. Since these side lengths were the same when I multiplied both of my original sides by 1.5, that means this image here is correct. And I don't need to check this last one because the instructions say to select two that apply, and I have found my two correct answers. Alright, our next question says, if you draw a triangle with these measurements, which kind of triangle would it be? Okay, so it looks like my angle measures are going to be 35, 55, and 90 degrees, and my side lengths are going to be 3, 6, and 8. So right off the bat, one thing that's sticking out to me is this 90 degrees here. And the reason why this 90 degrees is sticking out is because that is a right angle, which means I'm looking at one of these right type of triangles, so I know it's not going to be acute. Okay. The next part we need to look at is our side lengths. And if I look, all of my side lengths are different. None of them are the same. So since all of my side lengths are different, that means I'm going to have a scalene triangle. A scalene triangle, remember, does not have even sides. Equilateral, however, has 3 even sides, and if I look back at my side lengths here, these are not even, they're all different, which is why I have a right scalene. Alright, next question says that a triangle has two angles with measures 50 and 70 degrees joined by a side length of 24. Which figure represents this triangle? For this image here, what I suggest doing on these is taking your two angle measures, okay, so I have 50 degrees and I have 70 degrees, okay, and then it says that they are joined by a side length of 24. So if I have a point here, and a point here, I need to connect this line right here to join these two together. Okay, if I were to join, say, this bottom side here, well, this line only connects to the 70. It's missing the 50. Oops. And same thing on the other side. If I were to do it this way, this line only connects to the 50. It's missing the 70. So what I am looking for is something that looks like this on these images. Okay, I'm looking to have 50 and 70 be on the same line and then have a 24 in between them. Alright, so if I look down here, here's my 50 and 70, so here would be my line that connects them both. However, this 24 is in the wrong spot. It needs to be down here. This side length is a 50, so that's immediately wrong. Same here, this side length is 50, so immediately out, which means that this one over here is going to be correct. Notice how if I look at this part right here, here's my 50 and 70 degree, and this side right here that connects them both is labeled with that 24, which is what we are looking for. Alright, next question says use the given conditions to determine if the number of possible triangles. Do the given conditions create a unique more than one triangle or no triangle? So the first thing we want to do is look and see what type of information are we given. And I can see right here that we are given 3 different side lengths. Okay, so we have 3 different side lengths. Okay, so if you remember from our workbooks and our checkpoints, we need to use something here called the triangle inequality theorem, which is where we take 2 of our side lengths, add and subtract them together, and then see if our third side is going to be in between those 2 numbers. Now here it doesn't matter, we can pick any of the 2 sides that we want. I'm going to pick this the 5 and the 7, just because those numbers are a bit smaller, so adding and subtracting them is going to be a little bit easier. So first, let's do our addition. 5 plus 7 equals 12, and then our subtraction, 7 minus 5 is 2. So that means that the third side of my triangle can be any number in between these 2 here. If I look, this problem is giving me a third side length of 15. Well, 15 is definitely bigger than 12, and it's too big. In order for this to be an actual triangle, my third side needs to be in between 12 and 2. So because of that, there is no triangle here. If I were to draw this with accurate measurements, I would get something like this. I would have my 5 feet, 7 feet, and then my third side would go all the way like this. And although you may say, well, there is a triangle there, it's not a complete triangle, because in order for it to be a complete triangle, it'd have to stop right here, and it could not keep going. So that is why this triangle is not a triangle. Alright, next question. So a triangle has two sides that are 7 and 12 centimeters. What could be the length of the triangle's third side? So again, this is the same type of problem we did before, except now we're picking all the possible side lengths. Our numbers that were given here are 7 and 12, so again we want to add them together. 7 plus 12 is going to be 19. And then we want to subtract them. 12 minus 7 is going to give us 5. So any of the possible side lengths can be any number in between these two, but not including. So it can't be 15 and it can't be 5. However, it could be 18 or it could be 6. So 4 is too small. 21 is too large. 18 is in between those. 9 is in between those. 14 is in between those. It is not 19 because remember it cannot be the numbers that we get. So it can't be 19 and it can't be 5, but it can be any number in between them. Next question says that a student draws a quadrilateral that has two sides measuring 4 centimeters and two sides measuring 9 centimeters. The opposite sides to each other are parallel. What do the following quadrilaterals could the student have drawn? Okay, well, I know that two sides are 4 centimeters. Whoops. So two sides are 4 centimeters, and the other two sides are going to be 9. Here are my 4 centimeters, 9, and I know that these are going to be parallel. So right off the bat, this looks like a rectangle. And remember that a rectangle, a rhombus, and a square are also all parallelograms. So for this question, we would pick rectangle and parallelogram. Alright, next question says that the diameter of a dinner plate is 12.7 inches as shown below. What is the approximate circumference of the plates? So for circumference, okay, remember we want to start out with our formula. Circumference is equal to pi times diameter. The diameter of my plate is 12.7. So all I need to do is take pi and multiply it by 12.7. For pi, use 3.14. So I'm going to type in 3.14 times 12.7 into my calculator. 3.14 times 12.7. And I get 38.87, which is very close to 40 inches. It's very close to 40 inches. Our next question says that if the line BC is the diameter of the following circles, so this here is the diameter, what is the area of the circle? Okay, so let's first count how many tiles across I'm going with this diagram. So if I look here, I am going starting at B, 1, 2, 3, 4, 5, 6. So my diameter here is going to be 6. I'm trying to find the area. My area formula is pi r squared, okay? Remember, radius is half of our diameter. So in order to find our radius, I need to take 6 and divide it by 2. 6 divided by 2 is going to give me 3. So I'm going to have pi times 3 squared, which is 3.14 times 3 squared. And remember that 3 squared is 3 times 3. So at this point, I know all my numbers, so I can pop them into my calculator. Actually, I don't need to, because if I look at my answer choices, I have them in terms of pi, meaning all I need to do is multiply out my radius, and when I multiply out my radius, I just need to attach my pi to it. So if I am thinking about it, I need to do 3 times 3, which is right here. 3 times 3 is going to give me 9 pi. Okay, so again, I counted my steps from B to C. that was my diameter, so I had to divide that by 2 to get my radius, which is 3, and then I needed to square it. So 3 times 3 gave me 9, and then I just need to attach my pi. Alright, this question here uses a formula that we only really had to solve for once in one of our workbooks when we were doing this lesson. And that formula was it is area is equal to circumference times your radius divided by 2. And it's okay if you don't remember this because we don't ever use this. However, we're going to use it for this one problem here. And when we know this, it makes it a bit easier to solve because it tells me that my circumference is 2.56 pi. So right here for circumference, I'm going to replace that with 2.56 pi. And then it tells me that my radius is 1.28. So right here where my radius is, I'm going to put 1.28, and this divided by 2 is still going to be there. So my answer is going to look like this. 2.56 pi times 1.28 over 2. Alright, next question. It says angle A and angle B are adjacent and complementary angles. So adjacent and complementary. The measure of angle A is 62 degrees. So this word complementary right here is going to tell us a ton about how we're going to set up this problem. Then it says if B is the measure of angle B, which equation represents the relationship between the angle measures? So if you remember, complementary means a 90-degree angle, okay? And here's my line in between separating angle A and angle B. It tells me that angle A is 62 degrees. So if I wanted to figure out what angle B is, when I add these two angles together, I should get 90 degrees. So these two options that say 180, I know that those are wrong right away because this question is complementary. So if I were to take angle B, and add it to 62, I should get 90 degrees, which is this one right here. Alright, our next question says that angle B and angle C are supplementary. So again, this word supplementary is going to tell us a lot about the setup of our problem. If the measures of angle B is 14 times the measure of angle C, which equation can be used to find the measure of angle C? So supplementary means that we have two angles that add up to 180 or a straight line. Okay, so I'm going to have angle B over here and angle C right here. It tells me that angle B is 14 times the measure of angle C. So if angle C, let's say angle C is just x, because I don't know what it is, it's just x. And B is 14 times, which means I would have 14 times x. Okay, so this 14 times tells me I need to have 14 times x. And then remember that supplementary angles are whenever I take my two angles B and C and add them together, I should get 180. So I know B is 14x, C is x. When I add them together, I should get 180. So 14x plus x is going to give me that 180. Our next question wants us to answer, so it's the same exact setup. It says that if the measure of angle B is 14 times the measure of angle C, what is the measure of angle B? So I am going to be asked, well, what is this angle measure B here? And I'm going to use that other equation that we just did to solve this. So I had my 14x, and I had x here. So 14x plus x equals 180. So if I add these two together, if I have 14 x's and then one more, I would have I would have 15x is equal to 180. In order to get x by itself, I need to use inverse operations. So 15 is being multiplied here, so I need to divide both sides by 15. And I get x is going to be equal to 180 divided by 15, and I can type that into a calculator really quick. And when I do, I get 12. So this is where you have to be careful. So I know that x is 12. That does not mean that my answer is 12, okay? Remember that I am trying to solve for angle B here. And angle B is going to be this larger one. Let me change my pen color. Angle B is over here, this bigger one. Angle C, which is this small one, is 12 degrees because that is what x is. But I have 14 of these 12s. So in order to figure out the measure for angle B, I need to take 14 and multiply it by 12. Okay, so if I take 14, multiply it by 12, I should get 168. So my final answer here is going to be 168. So 168 degrees is the measure of angle B. All right, and then the last question says that angle B and angle C are supplementary. If the measure of angle B is 14 times the measure of angle C, what is the difference between the two angles measures? So we already know a lot about this setup because it's the same exact setup 3 times in a row. And based off of that last question, I know that angle C is 12 degrees and angle B is 168 degrees. Okay, I need to know what is the difference. The difference is subtraction. So for this question, all I'm going to be doing is subtracting those two numbers that I already know, 168 and 12. So if I do 168 and I subtract 12, I should get 156. And remember that you can type this into a calculator to double check your answer. But again, all we're doing here is subtracting those two angles that we already know. Okay, this was the last question for your Exam 5 review. If you have other questions or would like another attempt, please send me a message or an email, and I hope you have a great rest of your day.